Starting a new Flutter project usually means watching 3 to 5 days vanish. Before you write a single line of feature code, you are forced to make and implement heavy structural decisions. Commit to an architecture pattern, select a state manager, and wire up a routing strategy. If you turn to standard tutorials to figure this out, you will quickly hit a wall. Tutorials teach these concepts in perfect isolation, but a production app requires them to communicate constantly as an interconnected system. When you manually bridge those isolated concepts, you introduce setup drift. Every developer makes slightly different wiring decisions, and as your team scales, those small inconsistencies harden into spaghetti code. Instead of building test apps from scratch to study these patterns, we are going to use a visual scaffolding engine called FlutterSeed. We will use this engine to generate 2 distinct production-ready codebases, one entirely wired for BLoC and the other for Riverpod. This comparison table shows the overflowing list of packages required just to configure state, routing, backend, and theme. Automating this setup creates a perfectly controlled laboratory. By removing the manual wiring variations, we can definitively evaluate how these two architectures perform side by side. On the FlutterSeed visual graph, you drag and drop your tech stack. For our test, we set the routing to Go router, connect a Firebase backend node, and select a feature-first architecture pattern. Clicking Export immediately produces an idiomatic codebase. The generated zip file contains a folder structure that passes all standard Flutterlins the second you extract it. Looking at this flowchart, you can trace the mechanics. Node graph decisions feed into a handlebars template engine, dynamically writing Dart code. Notice how this bypasses the dependency conflict maze. You skip the friction of forcing mismatched packages together. However, that friction is usually how developers learn the ecosystem. By skipping it, your responsibility shifts. You must deliberately study the generated pubspec.yaml to understand why the engine paired those specific versions together. Accepting that generated baseline provides a pristine foundation. Because the underlying routing and architecture are wired identically in both projects, we can conduct a scientifically isolated comparison of the state management tools themselves. Let's examine the BLoC implementation first. When we select the Flutter-BLoC node in the builder, the template engine imposes a strict set of rules on our codebase. This matrix illustrates the output. The left side shows a rigid folder hierarchy for events, states, and blocks. Building features means constantly switching between these files, requiring heavy boilerplate. But this strictness yields a traceable architecture, an impenetrable shield preventing developers from breaking core logic. Next, we select Riverpod. Returning to our split screen, the right side reveals the Riverpod structure. Global providers connect directly to UI widgets via fluid, hook-based consumption, drastically reducing boilerplate. The hidden risk? Without discipline, those global providers easily degrade into a tangled, hard-to-debug web. In the BLoC project, dependencies are injected down the widget tree using specific repository providers. In the Riverpod project, widgets simply access a flat scope of global providers. This shift in how components request data illustrates how your choice of state manager dictates the entire dependency injection strategy. Ultimately, this choice dictates whether your app's complexity will be managed by strict systemic rules or by the individual discipline of your engineering team. Evaluating these side by side proves that choosing state management isn't about objective superiority. It is entirely about matching your architectural constraints to your team's reality. This scenario matrix breaks it down. On the left, we look at the ideal environment for the BLoC scaffold, large enterprise organizations and agency teams. In those environments, the strict generated boilerplate acts as a safety net. It ensures that a team of 10 developers working concurrently will write features the exact same way. Conversely, the Riverpod scaffold targets solo developers, indie hackers, and early-stage startups. When your primary goal is speed, Riverpod acts as an accelerator. It gives you the flexibility to ship an MVP fast when you simply do not have the time to write extensive boilerplate. Traditional tutorials often leave you to guess how folders, state, and routing actually connect in a production environment. The visual builder lets you see those connections immediately. You can reverse engineer professional-grade architecture from a contextualized, working codebase rather than piecing it together from separate articles. As this quadrant chart shows, utilizing this workflow requires a trade-off. You have to accept an automated baseline with opinionated defaults rather than handcrafting every custom edge case yourself. Saving 10 to 20 hours on foundational setup provides massive leverage. It eliminates the repetitive wiring, allowing you to focus your energy directly on building the unique features your users actually care about.